Hello dear viewers, I am Khan Bahadur, Assistant Professor of Statistics, and you are watching a video from my YouTube channel Statistics by Khan. Dear viewers, I hope all of you will be doing great. Dear viewers, this YouTube channel Statistics by Khan has been created for basic statistics with a view to help the beginner students of statistics, the researchers of all fields, and other learners of basic statistics. I have also a Facebook page and group with the same name, Statistics by Khan. You can visit them for steps related to basic statistics. Dear viewers, for better understanding of concepts in my video, I would recommend you to watch the full video. After watching the full video, I assure you, you will understand the concepts very clearly. In today's lecture, we will know about the weighted arithmetic mean and the unweighted arithmetic mean. But before the computation of the weighted arithmetic mean and unweighted arithmetic mean, let's know about what weights are. Weights are those quantities which show the relative importance of the values of a variable. What do I mean by this? For example, we have a variable x whose values are 11, 12, 13, 14, 15. Now, we have a data set in which different values of x have been occurred. I mean, a data set in which 11, 12, 13, 14 and 15 have been occurred, but 11 has occurred 2 times, let's say. 12 has occurred 3 times, 13 has occurred 7 times, 14 has occurred 4 times, and 15 has occurred 1 time. So now, what is this 2? This 2 is the weight of 11. What does it show? This 2 shows the importance of this 11 in the entire data set. In the entire data set, there were 17 data points. 11 has occurred 2 times, 12 has occurred 3 times, 13 has occurred 7 times, 14 has occurred 4 times, and 15 has occurred once. And all of them made 17 observations, 17 data points for the data set. So now, this is W column. What does this W show? It shows the relative importance of each value of the variable. In statistics, these are called weights. Weights of what? Weights of the values of the variable. On the other hand, if we have a data set that contains 5 observations, and each of the observation has occurred only once. For example, 1, 2, 3, 4, 5. Now, the importance of each one of them is equal, or the importance of each one of them is identical. What do I mean? Each one of the observation has occurred only once. 1 has occurred only once, 2 has occurred only once, 3 has occurred only once, and similarly 4 and 5. So that is why there is no weight. In this case, all the values of the variable are equally important. But in this case, all the values of the variable are not equally important. Some of the values are more important and some of the values are less important. So if all the values of the variable are not equally important, so then we represent the data set by weights. But when the values of a variable are equally important, then we don't show their importance with the help of weights. But in statistics, we don't show this weight column by W, rather we show it by frequency, because these weights are actually the frequencies. So we are representing this column by F instead of W. So it sometimes makes confusion for the students that what weighted arithmetic mean in fact is. Though they know the arithmetic mean from frequency distribution, but whenever there comes weighted arithmetic mean, so they get confused. So for this purpose, I wanted to explain you what weights are. So next we are discussing the weighted arithmetic mean and the unweighted arithmetic mean. So first of all, we will discuss unweighted arithmetic mean. Unweighted arithmetic mean. So there are 2 situations for unweighted arithmetic mean. That is, if in a data set all distinct observations have been occurred equal number of times. So in that case, if we compute the arithmetic mean, that would already become unweighted arithmetic mean. For example, we have data points 1, 2, 3, 4, 5. So these are 5 observations and each one of them has occurred only once. So if we compute the arithmetic mean from this data set, then the arithmetic mean would automatically become unweighted arithmetic mean. Similarly, if instead of 5 observations, we have 50 observations, means each of the observation has occurred 10 times in the entire data set. So it is identical if each of the data points has occurred only once, because the importance of each of the observation is equal. In that case, the arithmetic mean would become unweighted arithmetic mean automatically. But the third case is that if each of the observation hasn't been occurred equal number of times in the entire data set, but still we ignore the number of occurrences for each of the data points and compute the arithmetic mean. So in that case, it will also be in unweighted arithmetic mean, because the relative importance has been dropped or the relative importance has been ignored. So in that case, it would be again unweighted arithmetic mean. For example, we have a data set 1, 2, 3, 4, 5. So if we compute the arithmetic mean from this data set, this will automatically become unweighted arithmetic mean, because each of the observation has occurred only once. Similarly, if 1 has occurred twice, 2 has occurred twice, 3 has occurred twice, 4 has occurred twice, 5 has occurred twice. So in this data set, each of the observation have occurred equal number of times. It means 1 has occurred 2 times, 2 has occurred 2 times, 3 has occurred 2 times, and 4 has occurred 2 times. So if we compute the arithmetic mean from this data set 2, so it will again be in unweighted arithmetic mean, because the weights are equal. Similarly, if we have a frequency distribution, so if we compute the arithmetic mean by this method, so this is again unweighted arithmetic mean. So if you ignore these weights, so it will automatically become unweighted. But finally, if we take the values of the variable along with the corresponding frequencies and compute the arithmetic mean, then that arithmetic mean would be the weighted arithmetic mean. What do I mean? If I'm taking the values of the variable with respect to frequencies and computing the arithmetic mean, so in this case, the formula of the arithmetic mean would become, if I assume this is a sample data, so the notation for the arithmetic mean would become x bar, and the formula would become summation fx divided by summation f. This is direct method. So simply multiply f and x. So if we add this column, so we will get summation fx is 220. So plugging the values, x bar would become 220 divided by 17, or x bar would become approximately 13. So this is the arithmetic mean. Now this arithmetic mean is the weighted arithmetic mean. Why? Because these are the weights, and these have been taken into consideration while calculating the arithmetic mean. So this is the weighted arithmetic mean, because the relative importance of the values of the variable have been considered. So if in the calculation of any measure, the corresponding frequencies or the corresponding weights have been considered or have been taken in the computation, then all those measures are called weighted measures. So the computation of the arithmetic mean has already been shown, but with this simple example, I wanted to show you the difference between the weighted arithmetic mean and the unweighted arithmetic mean. Here the purpose was not to learn the computation, rather to learn the difference between the weighted arithmetic mean and the unweighted arithmetic mean. So that's all from my side for today's lecture. Thank you for watching the video.